In this video, we are going to look at vector fields. Under vector fields, we have a whole lot of topics to be treated. I'm going to start with the line integral. Now, first of all, what is a vector field? If you have a function of this form, then it's said to be a vector. So this is the x component and this is the y component. So here, the p of xy tells you that it's a function of x and y. So the p of xy can be either a scalar form or it can be a function of x, y. So when you have a function in this form, it's said to be a vector field. Now, under vector field, we are going to look at line integral. So with line integral, we are going to look at parametric equations as well. Now, if we want to know what line integral is, if we have a function of this form or an integral of this form, then it's said to be a line integral. So the C here tells you that you are finding the line integral of a curve. So this form tells us the integral of a function, which is the line integral. So with the line integral, you have the ds. The ds is the path along the curve. So now to find your line integral, you must know your parametric equation and also your ds. Every curve or function has its own parametric equation. So here I'm going to consider two of them, which is the circle and a linear function. So when you have a circle, that's s squared plus y squared is equal to r squared. Its parametric equation becomes s equals r cos t and y equals r sin t, and it has the t, that's the angle, with a limit from 0 to 2 pi, that's 360. If you have a linear function, its parametric equation becomes s equals t and y equals f of t. You see here, s is equal to t because the function is of x. But if it was a function of y, then y would rather be equal to what? T, and x will be equal to what? F of t. So here, we are going to look at our first example on how to find the line integral of a curve. So here, with this particular question, we are asked to find the line integral of this function, that's x y power 4, where the c is a right half of a circle. X squared plus y squared is equal to 16. So first of all, we must first find our parametric equation. Without our parametric equation, we can't find our ds. So from above, we're able to know that the parametric equation for a circle is x is equal to r cos t. So here our r is 4. So 4 cos t, and y is equal to r sin t, which is equal to 4 sin t. So now we must find the x dt, dy dt, so that we can insert that into the ds function to find our ds. So in finding dx dt, you are differentiating this with respect to t. If you differentiate cos, you get minus sine. So you have minus 4 sine t dy dt. So if you differentiate sine, you get cos. So you have 4 cos t. So now we put this into the ds function to get our ds. So we have the s is equal to 4 cos t plus 4 sine t square, which which is 16 cos square t plus 16 sine square t. So you can have 16 cos square t plus sine square t. Now we know that this is a trig identity. So cos square t plus sine square t will give us 1. So you end up getting root of 16, which is equal to 4. So we have the s to be equal to 4. So now we then move to the line integral formula. So now we know our ds. So now to find our line integral, we must then know the limit of the integral. So from the question, it says that it's a right half of a circle. So if we have something like this, so this 0 pi onto 2 pi, that's the right side. Then that's the clockwise direction. So now in the other direction you have minus pi onto minus 2 pi. So right half, this is the right half of the circle. So the limit is from minus pi on 2 to pi on 2. So we have our t to be between pi on 2 and minus pi on 2. So now we have our integral from minus pi on 2 to pi on 2 of x. Now x is, so now we come to the question. X is what? 4 cos t. So we have 4 cos t, and y is 4 sine t. So 4 sine t power 4. Then our ds is 4. So now here we have minus pi on 2, pi on 2. Then we have 4 power 4, which is 256. So 256 times 4, that's 1024 times the other 4, which is 4096. So you have 4096 cos t sine t. So to save you the stress, you can put your calculator at radian, and then you compute for this. Then you will get around 819 something. Let me check with my calculator. That's 8192 over 5. Then this becomes your answer. So like I said, to save you the stress, you can put your calculator at radian, and then you compute for this. You get 8192 over 5 to be your final answer. Thank you.